welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Mayfield. And in this video, I'm going to be working on that Section D checkpoint. So this is kind of all of those different sections, but it has them kind of together. It's a little bit more of a challenge, but again, this is what you should be working on after your first attempt at that quiz. Make sure you're taking your time during that quiz, and make sure you know you have 2 total attempts. So if you didn't do well on that first time, maybe go back, review some of the notes, go back over the videos, try some of those IXL sections, make sure you're understanding, and then you can do that second attempt. So for this question, I'm gonna try to get to 80, and we'll see if we can do that. So for that next part, it says which lists contain only, so again, only rational numbers. And so it says select all that apply. So I can, again, since it has that check mark, I'm going to say I need to select multiple answers. So again, I have some square roots here, but I know my perfect squares pretty well. Hopefully so do you. And so I know that all these numbers are perfect squares. However, I know that these, I can check one of them. I could say, all right, square root of 35, not a perfect, or excuse me, square root of, let's do square root of 31. How about that one? Still not a rational number, and so that means the entire list is not going to work. So again, it's saying only rational. So if even one of those is irrational, that means that we cannot select it. So now for the next one, those are all integers, and so those are rational. All those decimal values, they repeat, and so we know we have rational numbers for there. And for that last list, I'm going to select it as well because those are all fractions. So now for this next one, it says determine whether each number is rational or irrational. So again, I'm going to be categorizing or switching between these. So again, if I have a mixed number, you see that little ratio right in there. And so I'm going to say, I know that's rational. Again, if you need to check the, let's say the decimal value, I can say 4, and I'm going to say and, meaning we're going to include it. And we have 2 over 3. So again, it does not end. However, it does repeat. It has all those 6s in there, and it has that pattern. It's a fraction. It's a rational number. For that next one, we have the square root of 121. That should be 11, so let's check it out. Boom. I know my perfect squares, which are rational. And so now let's check out this one. It says it has a fraction, and it has the negative and then square root of 49 over 3. So let's type it in exactly how it looks. So we have a fraction. What I can do again, I can move between the top and the bottom, or the numerator and the denominator with my arrow keys. And I can say, all right, in the numerator, I have the negative, and then I have square root of, and then 49. On the bottom, or the denominator, I have 3. And it already evaluates it for me. So if you wanted to on the side, you could say, hey, I know that that's going to be 7. So I could say, I would have negative 7 over 3, which is the same value. Again, either way it works if you at least know that you're looking for this entire value. So now let's look at this decimal value. Well, we notice that, hey, it might not end, but however, it does repeat. And so we're going to say that is rational. However, for that last one, the square root of 12, let's type it in. Square root of 12, that's not a repeating or ending decimal, and so we know that's going to be irrational. And so now here's where it gets a little tricky. It says, what is the value of 0.6 repeating minus 0.3 repeating? Write your answer as a fraction in lowest terms. So you're going to have to go back and think, okay, how would I do this? Well, since it's asking for a fraction, I'm going to have to switch from this decimal form to a fraction. So what's a fraction that has 0.6 repeating? Well, we know that 2 over 3 is 0.6 repeating. And then it's saying, okay, we have minus, and then we have, what would be 0.3 repeating? That would be 1 over 3. Since we're subtracting fractions, again, you might need to go back and kind of review some ideas with this, but since those fractions are, anytime we add or subtract fractions, they have to have a common denominator. That means this bottom number has to be the same, and then we would just subtract the numerators, and so we're going to say this is going to be 1 over 3. Alright, so now for the next one, it says which decimal is equivalent to, again, that means equal, 1 over 7. So very simply we can do 1 over, let's try that again, let's do 1 over 7. And so we have this decimal, and if you notice, it ends up after that 6th digit, it starts to repeat. So it has that 142,857. It would have, if it had more spaces, I would also have 142,857 again. We know it's going to be rational, but it's just asking, hey, what's going to be that repeating decimal? And so we know it's going to be that value there. So now let's say, all right, back to those categorizing. Let's say, okay, which of these is rational or irrational? Well, that's a ratio or a fraction. That's going to be rational. For this number, it's not a perfect square. It's actually a prime number, and so that's going to be a square root of prime, which is irrational. However, the square root of 99, let's check it out. Let's do a fraction. We have square root of 99 over 3. Well, it doesn't look like it repeats or ends, and so we're going to know where that's going to be irrational. However, that last decimal value does repeat, and so it's going to be rational. I have a score to 80. I like to show off, so let's keep going. Let's determine whether each number is rational or irrational. Again, that's categorizing. I know for each of these, it actually, okay, I see now. So since it has that bar over the 0 and the 1, it's saying that would be, it would kind of look like this. It would be 0.0101. So each of those digits would keep on repeating like that. So it would be rational. This is rational. This is rational. However, for that last one, it's also going to be rational, but it would look like this. It would be 0.011111, like that, since it's only that one digit is repeating. Since it has decimal values that repeat or end, they are all rational. Enter in the challenge zone. I am ready. Let's do this. All right, so it says what value is, or let's try to read though. What is the value of 0.4 repeating plus 0.2 repeating? And it says write your fraction in the lowest terms. So let's see, I have, it should be, my guess ahead of time is it's going to be 2 or 3. So let's see if we can prove that. So let's see, what would be 0.4 repeating? I think that's going to be, let's see, I could do, is it 5? Let's try out some fractions here. 5 over 9 maybe? That's 0.5 repeating. So similar idea. Let's do 4. Let's do 4 over 7. Not close. Let's do, we need something a little bit smaller than that. Let's do about 3 over 8. Okay, getting closer. Let's do, let's actually see. I'm going to check to see. Is it going to be 2 over 3? Since I know that result would be 0.6 repeating, which is this value here. I should have gone and got in the first place. All right, it says select all the numbers that are irrational. Square root of 3 is irrational. Let's do, what does that look like? Well, it says 3 times the square root of 4. 3 times 2 is 6, so that's rational. We have a fraction, we have a repeating decimal. These 3 are all rational. However, these last 2 are not rational. And it says which decimal's equivalent of 5 over 6. I'm going to say it's going to be one of these that has the 8. I think it's going to be this one down here. Let's double check. So we have, what is it, 5 over 6. You better believe it, it's just that 0.83 repeating. So again, notice the difference between these two choices. This first one would look like this. It would have 0.83 and then 8, 3, 8, 3, 8, 3, 8, 3, like that. However, this last one, it just has the digit 3 repeating. The last one, again, it only took me 9 questions so far, kind of dominating, but let's keep going. Select all the numbers that are irrational. So I have an ending decimal or terminating decimal. Let's check this square root. I have a square root of 120. Oh, let's back up. 120. That's not a integer, and so we're going to say that's not rational. However, the square root of 121, that's an integer, and so we are going to include it. Again, any values that when we take a square root of it, if we say, hey, 11's an integer, we know that's rational. We have a repeating decimal, and let's check that last one. Let's do that square root of 136. That's not rational. Let's go for the crossing the finish line, and you better believe it, dominated again. As always, super slam that subscribe button.